moving money forward in time. And the more often we compound, in other words, the more often the bank looks at our bank account and adds interest to the principal and interest that's already in there, the higher the effective rate. Let's say we have 3 different potential investments with exactly the same risk. One promises a 12% return compounded annually. One promises 11.9% return but compounded quarterly. And the third offers 11.9 but compounded continuously. Well, to compare those and to figure out which investment we want to make, we'll have to figure out what the effective annual rate is. One way to do that is the formula. The effective annual rate equals 1 plus the nominal rate divided by the compounding periods per year. Take that and raise it to the power of the compounding periods per year and subtract 1. So let's do that real fast for 12. Since it's compounded annually, the effective interest rate should be the same as the nominal rate of 12. So order of operations, we'll start in here first, 0.12. So when we're using this formula, we have to use the decimals. We'll divide it by the compounding periods per year, which is 1. That gives us 0.12. Then we'll add 1 to that, plus 1 equals, and then we'll raise that whole thing to 1. This is the y to the x key, so that's sitting there. We'll hit y to the x, 1 equals, and then we'll subtract 1, and that gives us our 12%. So when we have annual compounding, our nominal rate is the same as our effective annual rate. We can also use our calculator to do that same calculation. There's an interest conversion menu under second 2, and we'll put in the nominal rate of 12. Here we won't use decimals. And then from here you can either hit up or down. I like to hit up. It asks you the compounding periods per year. We want 1, enter up, and the effective rate, compute, and there's our 12%. By the way, please notice I've got the calculator set to show us 6 decimal places. The most it will show you is 9, but please remember that the calculator does everything out to 13 decimal places. All right, let's do the next one. Let's hit second clear to clear everything out of that interest conversion menu. And by the way, for some reason it never clears the compounding periods per year. Let's clear the window. And what we're going to do is use this formula here to figure out what 11.95% compounded quarterly is equal to on an annual basis. So we're going to do orders operations, start early here with 0.1195 divided by 4, that's the compounding periods per year, equals that. Add 1 to that, plus 1 equals. Then x to the y, raise that whole thing to the 4th power, equals. And then subtract 1, minus 1 equals. And it tells us that the effective rate is 12.4963. And so it looks like it's a little better than 12% compounded annually. Let's do that same thing now, but let's use the interest conversion menu. Let's do the same thing, but use our calculator's module here. So we'll hit second interest conversion, which is the 2. It asks us what the nominal rate is. Well, the nominal rate is 11.95. So when we're using this formula, we enter the interest rate as decimals. When we're using the calculator's module, we enter it in as whole numbers, 11.95. Enter, and then again, you can go either up or down. Let's go up. Compounding periods per year is 4, enter up. And the effective rate, compute, gives us that 12.4963. See how the calculator takes it out to the 6 decimal places where I have it to 4 here. But we get exactly the same answer. The more often we compound, the higher the effective annual rate. What if the investment offers continuous compounding? So let's find the effective rate if the nominal rate is 11.9, compounded continuously. And that formula is a little bit different. It says take Euler's number, which is something like 2.71828, raise it to the annual rate that's quoted, that would be the 11.9 here, and subtract 1. All right, how the heck do we do that? Let's look at our calculator, and we see that there's a e to the x power down here. We'll input the quoted rate, which is 0.1190. We'll raise that we'll raise Euler's number to that. We'll subtract 1 minus 1 equals, and we'll get 12.6370. So of these three investments, the 11.9% compounded continuously is the best. To summarize, if we're comparing investments with different compounding periods, we'll have to calculate the effective annual rate for each of the investments, and we'll choose the one with the higher effective annual rate, assuming the investments have the same risk. We can do that conversion pretty easily using either this formula down here or our I conversion menu, which is at second 2 in the calculator. Unless it is an investment that offers continuous compounding, and then we can't use that second interest conversion menu, we'll have to take Euler's number and raise it to the power of the quoted rate and then subtract 1.